5-volt power supply are the most common electrical resource that we use. For instance, to charge our smartphone battery, we usually use those 5-volt power supplies. That is one of the most significant use. Therefore, the production of these circuits is very common. The thing is that the main component is a transformer. That is why this project is different. In this project, we are looking for achieve the same behavior of a 5-volt power supply but without the transformer. So if we want to get those values without a transformer, we have to use other electrical components that bring use the possibility to rectify the voltage and also manage a specific value of voltage no matter which input voltage we have, because we need a power supply that keeps 5 volts in any case. In this point, we introduce the rectifier diode, Zener diode, ceramic capacitor, electrolytic capacitor, and resistances in the development. Due to the management of current in very component that we will use in the circuit, we have to take care about the management of electric power, because every component will support a defined value of electric power, and each component has a defined value of tolerance of electric power. That is why we need to make sure and calculate how much electric power the components have to deal with. In addition, each component will produce some heat. The electric power and the temperature are related because a charge movement exists, and the movement depends on how much current is passing through in the component, and this is the cause that we modify the temperature.
The team started with the research of established circuit diagram using mentioned elements. Once the team got the diagram, simulation began. Using multi-sim software, the team implements the diagram and then makes some tests using virtual tools given by the software. They provide that using rectifier diodes that deal with at least 100 volts, 5.1 volt Zener diodes, resistors and capacitors. The main objective is already done. We got 5 volts power supply and 54 milliamperes at the least on the simulation. Finally, using the virtual tools given by the software, the team analyzed the wave behavior and discovered that the input wave is a sine wave at 60 Hz, and the output wave is not what team expects because it has a square wave behavior. I didn't look like a stable DC voltage. The test demonstrated that the circuit without the transformer give average voltage of 5 volts, but the analysis of the wave with a virtual oscilloscope demonstrate kind of square wave working almost at 50 Hz. Then the team proceeded to design of PCB that gives the commodity to weld the elements over the board using the less possible area to get a cheap board and also a well-designed PCB that deal with heat and cover a little space, giving a handy board ready to use.
Teamwork in the laboratory. The first step is mount the elements on the protoboard. following the circuit diagram developed in the software. Then when the team mounts all the components, the next step is make some tests related to the expected voltage and current. The results that the team looked for were archived. The circuit was deployed almost 40 minutes to secure the appropriate work of every element has a stable sequence. Then to get more realistic output values, the team welded the elements over the PCB, taking care of not damage the board and also secure that the connections don't touch each other. The final dimensions of the PCB were 6 cm wide and 2.5 cm height. Two blocks of connections were added to make the output test comfortable and easy to change the output resistance values.
As a conclusion, the team agreed that take care of every single connection is important. Don't verify the electric power of an element could turn into a very dangerous situation. And more in our design cause we implement an electrolytic capacitor, and if an element is burning, it could modify the current direction and explode the capacitor. Also, verify the heat of every element is important. If the board can't handle certain temperature, it won't work properly. It's important to use every available tool. In this case, the thermal camera and the laser temperature gun give us important information. Even though the camera display overrated values that don't make sense compared with the laser gun. But the camera gives us a very good image about how the heat was distributed over the board, highlighting the areas in which the heat was high, the input of the circuit, and also an area with lower temperature, the rest of the circuit. The laser gun gives us more specific values of temperature in different elements, as we can see in the pictures, proving the high temperatures on the input of the circuit. At the end, the team could say that the objective was good. The circuit gave 5 volts average power supply and also a current of more than 50 milliamperes. These values with a well control of electric power and current, a circuit that could work for more than 1 hour without problems of overheat.